Hello, and welcome to the final speed run of chapter 4.4. So we'll be covering how to draw the original graph from its derivatives, and yeah, so let's do that. So the one thing is, it is actually technically impossible to graph the original graph from the derivative unless you have a coordinate on the original graph. And we'll get more into that when we discuss integrals and integral calculus. But with that being said, let's look at some questions. So the first question we have, again, I'm doing the even ones today, is the graph. The derivative looks something like this. This is the derivative, and we need to sketch the original graph from this. Quite interesting, actually. So given that this is the derivative, well, the zeros on this derivative will be the maximum and minimums of the original graph. So as you can tell, this is negative, this is positive, so this will probably be a minimum somewhere. This is negative, this is a positive, this is negative, so this will be a positive turning point somewhere. This will be a maximum, minimum, and then we have like another maximum maybe somewhere here. Again, we're just kind of estimating where all of these points will fall. And so our final graph, if we just join up all these points, will look something like this. Maximum, minimum, maximum, and yeah, it would go on something like this. So again, the graph doesn't have to be completely accurate. You just need to have a general understanding of where all the points would be. Okay. On to the next question, and it is again giving us a derivative, and we have to find the original graph from it. So first we have a dip, up, dip, peak, dip. So what's interesting here is that this actually isn't a real turning point since the gradient is staying positive on both sides. So this probably is just where the graph touches zero. We do, however, have real turning points here, here, and here. So between, this will be a maximum, since we're going from positive to negative. Say the maximum is here, I don't know. Then this will be a minimum, and this here will be a maximum. I don't know, I'll just call it over there, I'm not too sure. And so if we join all of these points up, we will get a graph that looks something like this. Minimum, maximum, let's try that again. Maximum, minimum, maximum, and then down, because we have a positive, negative gradient. So yeah, I think we have just one last question for this subchapter, and we're given the second derivative. This case goes up, down, up. We're given the second derivative, and we need to sketch the graphs of both the first derivative and the original function. So for the first derivative, we know that the zeros on this graph will be the maximum and minimums on that graph. Actually, this should be extended down there. So this should be a minimum, maximum, minimum, maximum. So let's just roughly sketch out where these points could be. So we'll say that's a minimum. This is a maximum. This is a minimum. And this is a maximum. So we will get maybe something that looks a bit like this. Yeah, and then so now we need to get the original graph from this function. So as you can see, we cross zero here, here, and here. So the original graph, this is a minimum, so we can say it's like here. This is a maximum, so we can say it's like there. And this is another minimum, so we can say it's here. And so if we connect the dots, we will get an original graph that looks something like this. I think I'm curving a bit more up on this side, but yeah. So that was it. That's all for the speedrun. and for the subchapter really, so I hope you're confident in using derivatives in a graphical way. See you in the next chapter.